Hello, this is Kapil. Welcome to part 2 of building r/place with Clojure and Clojurescript. If you haven't seen part 1, please do check it out. It's in the description. Today we are going to build some backend, build more of the backend stuff. Before that, I'll just do a quick revision of what we have done so far. So we built this UI. We have our go-to diagram to understand what we are trying to do. This is your UI and the backend. Uh, we are rendering the UI with the canvas, which is kind of being sent from the backend, which has the persisted state, and it's sending all the updates to make sure the latest state of that canvas is rendered. We are also sending all the canvas clicks back to backend to persist it. This is the part that we have not done. So if there is a click on one of the UI clients, that is not broadcasted to other UI clients. Is to highlight this concept even better. Uh, this is one of the user who's looking at the canvas, kind of interacting with it, but other users will not see it. Just to highlight it even further, I have kind of placed four windows parallel. So if I, let's say, click on first 3 pixels, it's not getting broadcasted to rest of the 3 windows. If I refresh, of course, it will try to fetch it from the backend. It is there, but the broadcast is not yet visible. So we need a system which will help us broadcast to rest of the clients. We don't need a concept of a room or a topic right now because we are assuming there is going to be one global canvas and that's about it. We might need some optimizations in the future because this is a smaller version of the canvas and we might have a bigger canvas which is like 10,000 pixels by 10,000 pixels. Uh, we might explore the concept of topics or groups there because at any given point you will just see a part of the canvas and not the whole thing. But for now, we'll just like create a broadcast system, assuming there is just one global topic that we are broadcasting to. Okay, so let's switch to the front end UI and let's see what we can do. Before that, there are like a few bugs that have crept in. One of the bug is when I click on the canvas to render something, the grid keeps getting darker and darker. This is because in the handle click handle canvas click, we had this draw grid, which I have removed now. Uh, Let me recompile this UI because this events listen canvas is going to get added to uh, the handler is going to get added every time I render the page, and there is no way to undo this from the REPL, right? Because it's already done. Uh, there is a way to kind of clear all the click handlers, but the cleaner way to just recompile this and let uh, JavaScript do its magic. While this is recompiling, we'll just look at the backend code now. All right. This is not the backend code. All right. So on receive handler, we are like kind of looking at the channel and data. Let's switch to our tuple and see what it stores. So we are getting a reference to the channel and data. This is basically when and canvas click event is being sent to backend, and it's persisting it here. What we need is a handler on connection of this WebSocket, so we can keep a record of all the connections that are being set up, right? So it's going to be this guy, where we are also kind of repeating our state and sending it to the UI. We also want to store this channel somewhere. So let's create a different state called all channels, and let's store it in an atom for now, in a hash map. I'm not sure what would be a good key to store it against. So for that, I would have to look at the request. Let me do this. Okay, so we have refreshed the page, switching back to backend. Okay, we have reference to r star. I'm going to just look at what is a good key that we can associate it with. Later on, this can be user ID. We don't have user authentication right now. So this could be replaced eventually with something like a user ID and timestamp. But for now, I'm just looking for something unique that we can store it against. I'm just going to use start time for now. Okay. Look at all channels. It's an empty hash map. And go back to front-end code. Refresh this guy. Oops. Go back to backend. Check all channels, and we have a reference to one of the channels that has been loaded just now. Great. So let me go to the front end grid, which is going to help us understand if broadcast is working or not. This should make the hash map contain 5 WebSocket channels. There we go. We can do a count, and it's a total 5. Okay, Now, all I have to do is reference to this all channels whenever I'm storing an update, right? This pixel data. I also need to broadcast this to the rest of the channels. So it will be something like all channels do seek which can do. But at the same time, we don't want it to send it to the same channel that produced the update. So we can do this should do the trick. Let's give it a shot on our front end grid. Yeah, this is still not working. So let's debug this guy. Okay, actually it's not even persisting in the backend, which means this is failing somewhere even before persisting. So there's a bug that we need to solve for. All right, I'm pretty sure this is where it fails. Let's try to seek channel and see what it prints. Ah, I see. So it is this what we want instead of just. So we need to destructure, because what we are doing here is kind of converting a hash map into a sequence, which is a sequence of key value pairs. We don't care about the key right now, we just care about the value. This is how we restructure it, and now we use that value to kind of send update. Let's recompile it, go back to our front end grid, and there you go. Can And if I refresh this page, it should work. I can try it from other places. It's still working. Now, there is a problem with this approach is the reference of channels, all the WebSocket channels, is going to be a ever-growing hash map. The reason for that is every time I'm kind of adding, connecting or refreshing the UI, it's going to set up a WebSocket connection, which is going to fire up this guy, and it's going to add one more thing to the channel, to the list of, to the hash map of the channels. Now we can decide where we want to clean this up, right? One way is to kind of clean it up here itself, where we are looking at the channel if it's not the same one, but we can also see if this channel is still open. Right. If it is open, we can send the update. If it's not, we just, in this case, we do need the channel key, and we upgrade all channels. This should do the trick. I referenced pattern incorrectly. Now we have something that will self clean itself. Let's try it out again. Switching to the UI. The update should just require one click and that run should clean itself. Steps again since I was not on the screen. So this is our on receive handler. We were wondering why it's not kind of removing the bad channels which are not now like not being used by any UI. So first we looked at filtering through all the channels from the hash map, and we got the count as we wanted, 5, but here it's still not doing the right thing. Then we wanted to check this part. We don't care about channel right now. We remove this, and then we realize that uh, we are actually checking if the channel is open from this active channel which was receiving the data and not from the list of channels which we are kind of holding on to. So this is where the bug is. Remove and change this. Compile this guy again. Now moving back to the front end grid and doing some interactions so we know that it works. Now going back to backend, and our hash map should just have 5 entries now. And this did not still work. Okay. Oh, okay. I'm changing the code. I removed the daysock. Let me just type it out again. All channels. And change this guy to CHK. Recompile. Move to the UI. Do a few clicks. Move back to backend. And do a count. Now we just have 5 channels, so it's cleaning itself also. We can try this theory again by creating one more window, just closing down one of the windows from this grid, or actually we can close down this window. We have in total 5 windows. Let's close this guy. Going to the front end UI and sending another update. Okay, sent a few updates. Switch back to backend. Count channel should go down to 4 now. Okay, so we have a very basic pub subsystem which is broadcasting to all the channels. Next up, what we want to solve, and I'm going to stop for part 2 here, but in the part 3 of this series, what we are going to do is, instead of keeping all the states of pixel clicks as a series of updates, which is going to kind of blow up the memory if we keep this running for long enough and on a big enough canvas. We just want to keep the latest state, but we do want to keep a history of these pixel clicks because that is how we can generate like a time lapse from the start of an empty canvas to just the collaborative graffiti over time. Uh, for that, we are going to try a different approach where we don't need to store it in memory. We could get away with storing that on a file. So there we'll see how we can interact with files, write to them, read from them if we need it for the time lapse. So that is up for the next part. Thank you for joining in. Bye bye.